Okay, looks like the stream's working. Sorry about that. Um, kind of maybe glitched out or something. I don't know. We'll see if it holds. I'm just gonna set up the stream and watch me work right now. Oh, that was quick. It's actually quite a quick setup for the pairing on Watch Me Work today. I'm just gonna pop out my chat here for YouTube. Oh, that was quick. It's actually quite. Hello, Birdor. Hello again. Thanks for joining the stream. Today I'll be updating our inventory system. I noticed I guess it'll be a sharing of and troubleshooting. I just noticed some oddities with some of the new item types, so I just thought I would explain what's happening, perhaps fix any issues that may be, or discover any issues that may be causing some conflicts. Alrighty, okay, so where we last left off, let us see. Odd that my controller is not plugged in. Oh, no, we're good. Right, so, excuse me. Yeah, I adjusted the item pack just for 3 items, so we know what's going on here. We're gonna just make sure everything's working, sort of working from the top down. First checking if we have pack capacity, and then making sure we have item stacking working. And I guess we'll be using these, this item type, the ferro alloy. So right now, pick up 3. We have 3, all 3 slots of our bag are being used. And then if we try to pick up anything, yeah, we get inventory full. So this is where we are right now. And what's happening is, or I guess how we're doing this, is that we have a, so on overlap, this is our item master, the parent class for all of our items. Basically on overlap with our character. The first thing we do is we clear out and reset variables that we use for counting. So this is I use this often with a lot of my inventory-driven blueprints or widgets. Just sort of for housekeeping, just clear out everything that we would need to check against. But the first thing I'm doing right now is, well, I guess let me explain. This is sort of what I'm working through, and that I want to check is working correctly. And in order to do that, including this actually, let's move this down. And I integrated this section, but that's, I can explain what that is. Basically, we have 2 halves here. The top half here is the item can get picked up and added to inventory, and the bottom one here is that, disables our pickup. So both of those are working. We checked against that. The check right at the end here is check if our pack is full or not. And that's all logic that's driving whether we can pick things up right now or not. Check to see if our item pack on our character. So, follow this wire back. Yeah, this is just a variable from our character class. Our pack capacity and our max capacity. Let's make this a little neat. And I'll shove this back here. Okay, so What I just set up here is, once we clear our variables, what we're going to be doing is checking our character's inventory for any matching, looking at each item in the inventory and looking at the item struct. We're checking the name to see if it exists already against our item master. This is what this is here. And if we do find it in a loop, as we're checking through the entire inventory, we either check for item is not found in array or item is in inventory. What we should have here, let's just duplicate this up. Once we find that item in our array, we can check true. Item is found in array, and let's make that a green maybe, just so it stands out. And then after that loop is completed, we come through here to a branch, and right now we're both routing into the same. We pick it up anyways, because we still have to check whether it's in the inventory or not. Doesn't matter based on this selection, because we're just checking for, hey, is this item in our inventory or not? Or sorry, is the pack full or not? Here we're checking for, is it in our inventory or not, which is useful for checking stacking, which will be like the next check after that. Oh, Kalorla, I am feeling pretty good. Starting the stream earlier because I want to. I have some things. I have an appointment actually in the evening that I have to take care of, so I want to make sure the stream is sort of available. So I don't run out of time or anything like that. But feeling pretty good. Okay, so let's take a look at where are we. Let's grab advanced this time. Right, so if we wait for our print string to clear, and we pick up this item, so we can see that loop checks for one item, two item, and now it found one in the array. And now of the 3 items in our array, it found 2 of them. And that sort of checks out, but a little bit of a glitch already. We're picking up more than we should. Everything else, yeah. I am not found in array. Yeah, so if the item is in our inventory, we pass it through here, and then we check our capacity, which is interesting. What I would like to do here is actually I have to blow this up a little bit in the print string. And we're using append string, and we're basically going to grab this, put a space of, and another space, and we're going to grab our max capacity, just so I can get a clear readout where we're sitting. As we're adding items into our inventory. Oh, is that right? Oh, forgive me. You know what? My bad. Good call. Thank you, Kilarla. You saved the stream. Credit goes to you. I forgot to change my scene here. My voice is duplicate. Interesting. I wonder what's causing that, though. Mute my desktop audio. Tell me if that fixes the voice issue. I believe I'm not playing it twice. On my restream, it's paused, actually. Yeah, let me know if this is better. Okay, anyways, let's see here. So 1, 0 of 3. 1 of 3. 3. So that puts us right back to where we were. Of course it does. Of course it does. I'm not sure as to why the audio is duplicated. I can check my device settings here. I only have one microphone input. So I'm not sure why it's duplicated. Anywho, I'll continue here. Add this item to our inventory. I'm going to pull this out here to debug against our play view. So we start with 0 items with a capacity of 3. And our capacity has increased. And now we can't pick up anything. I'm going to use Alt to duplicate a 4th one. I just want to test against if the issue is within this item or not. So it appears to be. Strangely, regardless of whether items in the inventory or not, we're still supposed to be checking against if it's less than, if our pack capacity is less than our max. These values are pulled directly from our character. Let's take a look at our the alloy actor itself. If we go into its data here, we have a max stack of 1, can stack. Let's check this out. in a very bizarre way. Um, yes, strangely, the pack capacity doesn't update when we're picking up the inventory. Here, you think it would. However, previously the item, this inventory system was sort of, we basically we launch our item menu widget uh, in a way to sort of, I believe, cross-reference this data. Um, so I believe that's actually the issue of why it's causing us not to almost ignore our pack capacity. So I'm going to set up that instruction as per how it was originally, our check pack. Because the inventory of items on the character is just an array. Oh, sure, Kalarla. Yeah, paste me a link here in the chat. I'll be happy to test it out. Be happy to test out a minigame. So, 3 items, and now it's full. So, interestingly enough, our character's inventory requires that we launch our menu in order to get that data. So we have this string here. It basically reads out how many item slots we have in our inventory, which is sort of that's interesting setup. I'm wondering if that could be better optimized or how we could better optimize it. Very bizarre. We have to figure out what's going on here. Hmm. Let's take a look at this. Add to inventory on our main. Anytime we add a new variable, we need to connect them. They are all connected though, so that's fine. Drives interactions on pickup. Update visuals. A little weird. A little weird because these are already um, we already set this to happen. So that means if we, strangely, if we just get rid of this, compile, we should be getting that visual update function. I just want to test this real quick. We'll drop down, 3 canteens here. And if we pick these up, yeah, we're still getting our visual updates. Not exactly happening for our water canteen. That is because that's just because we need to add a new case here for it. Yeah, really simply, we'll just write canteen, and we'll route that into our switch here. This one definitely going to be based on from Maya only, so we can just route that directly into that cast. So actually save and compile and play. We should get the visual feedback happening, and we shouldn't need any. Yeah, there we go. Cool. Yeah, it's kind of like a replicated function. It doesn't really have to be on the item master at all. It's a little unnecessary. Anywho, allows us to clean this up a little bit more, which is good. Whoops, save and compile our item master. That being the case, this drives interaction. If we add it to our inventory, for the sake of we have a inventory, but because we're not just working with. Let me think here. This original inventory system that's on the master that we check by opening our characters. We check our actual pack capacity by opening our inventory menu and then closing it immediately. That setup was pulled from a tutorial, I believe, where there was only a picking up and dropping of items and consuming them. There wasn't really anything as elaborate as we have in our game, where we have things like shops and other interactions that are item based, such as the stash box. Because that's the case, I feel as though we need to make sure we need to adjust our pack capacity on pickup. It shouldn't be something that we have to relegate to our item menu only, because the pack capacity needs to be referenced in different widgets, not just the menu, not just the readout of our array. So what we can do here, okay, pack capacity. So on pickup, assuming we have no item stacking, which is how we're gonna base this. Let's just move this up here for now. Probably something here, yeah. I like to work downwards. In this space, so we're adding items to inventory. In theory, we should get our pack capacity. Actually, we should get pack capacity. And we should increment it. That's what we should be doing every time, assuming we have no stacking of items, which we will. But for the time being, let's develop, from the top down, so to speak, adding complexity and functionality as we go. Oh, you can't put it in chat? Oh, it's so awkward. I wish we could. It's so much easier. Unfortunately, I don't manage the Facebook page myself. There must be another way for you to get that to me. Hmm. Um, let's see. Let's see. Um, I rarely ever use Facebook. You sent it on Facebook. So how does this setup work? Um, hmm. Um, I don't know, Kalarla. I don't. I'm looking at the Dead Cell Games page here. I don't see it posted. Like I mentioned, I don't manage the Facebook page myself. Um, but if you sent it to us in a private message or something like that, I can get it from my partner who does manage it. Anyways, I want to check and make sure this is counting now. Um, so we shouldn't be able to pick things up infinitely. Um, yeah, we're going to be working with these two pretty heavily. Um, and then we come through here. Okay, so 0 of 3, 1 of 3, 2 of 3. Now, we're at capacity. So I believe we shouldn't be able to pick this up. Perfect. It checks our whole array too for all 3 items. Our array is 3. It's capped at 3 for our inventory, and you can see that it checks and found 3 of them. So the counting does work. We just have to add some logic into our pack for the item stacking, um, which is actually going to be pretty fun. Actually, I think we'll make some pretty good use of our item struct in a pretty satisfying way. Alrighty, so let's see here. Let's see. Let's adjust our alloy, and let's just to make things a little bit easier. Let's say that it can stack, and the max it will stack is 2. So we can still use this same logic is into the inventory and check if the pack is full. So in theory, if we're always, not to say always, but if every time we add an item to our inventory and we adjust the pack capacity in this area, and we're checking to see item stacking here, we shouldn't need to do things like opening up our inventory and then immediately closing it just to check our stacking count, and it should clean up this a great deal. Alrighty, let's move this right here. Is item in inventory? Yes, it is. Well, if the item's not in our inventory, this is going to stay the same. We're going to just immediately check if the pack is full or not. Hold on. Check if the pack is full. Um, for open slots and stacking. So we probably do want to. What's going on here? Destroy actor. Oh gosh, that rewrote node. Okay. Anyhow. You know what, the first thing we have to do, I'm getting a little ahead of myself. The first thing we have to do is ensure that this item counter in our pack capacity is updating only if here, what would be the easiest way to do this? So we have 4 alloys. Each of them can stack twice in theory. So let us duplicate this so we have 6 of these out in our play space. So our inventory, max capacity right now is 3 slots. Now, if we pick up one, perfect, that text is not red, which means it's not at max. We have one item. So if we pick up another one, it's stacking, so that's perfect. But, oh, interesting. Very interesting. Because we're using this logic on our item menu. So it's already displaying accurately because we're in our item menu. But on our character itself, it's not. And I want to say that our menu needs to be driven by our character's count, not the count of how it's displaying data. Interesting. So let's go to our pause menu and item menu. Let's check this out. And inside of here, we have a very complex instruction. It checks if the item stacks are at capacity. Hmm. Let's temporarily. First thing I'll do is I'll do backup. I'll copy all of this stuff to, maybe like a backup graph. And here I'll copy everything, just in case my experiments prove fruitless. I want to have all this backed up. Um, Now we should have a all right. So now we can work back into our regular graph here. Let's close all these functions we don't have to have open. So, initialize delay, that's fine. Cast active character so that we can access it. That's totally cool too. Active, yeah. Okay, right here, we refresh inventory, triggers here. So, outside of clearing this, let's see here. The first thing we're doing is we're checking to see if items in the inventory are stackable. Okay. Yeah, so here, this is what's sort of causing our conflict with our pickup tracking, our new setup for inventory, pack capacity tracking. It's that at the end, this massive, like we're seeing how items are supposed to be displayed, but we're basically setting the pack here, and it overwrites our tracking on our pickup, on our actual character class. What we want to do is actually, I believe, we want to just do this right in our character on pickup, and then adjust the pack accordingly. Uh, and then this should be able to remain the same. except we just wouldn't be resetting this. It would just be getting these values. And there should be no conflicts because it's the same instructions, I believe. So I'm going to, how am I going to do this? Let's move my my chat windows around here. Let's move this down here. I'm actually going to move the reference, the item menu, off to the side here. So before I begin, let's just verify, for my own sanity, that our item menu is working as it's supposed to. We did back up a duplicate. Yeah, it's the exact same. That's cool. Totally cool. And we're going to set up our item count here, which is where it should be. We should be tracking our slots and our actual pack capacity as we're adding things to our inventory, not when we're opening up an item menu. So the first thing we do, interestingly enough, we're grabbing a lot of variables that exist on our main character, but I do have a feeling this is going to get pretty huge. We're going to break this for now. It drives interaction on pickup. It's just a cosmetic feature at this point anyways. And the first thing we're going to do is get our item stacking, because I believe we should be able to make use of our existing code as it is. So, first thing we're going to do in here, whoops. We're going to clear our data on our stacking counter. So let's clear this, and let's clear this. And deciding whether this should be done before or after our stacking. Well, for now, let's just... that can be switched around if needed later. Okay. Clearing anything else? No, that should be all that's applicable. We then want to, for each loop, based off of our inventory array, for each. Okay, so I'm going to rename this to clears all data. Can accurately stacking. And from here, we want to for each item in our array, we want to check if it's stackable. So and the way we do that is kind of awkwardly. We're going to just check for a break. We're going to check each item with a break, rather. So for each item in our array, we are going to check if stackable. Whoops, not that branch, excuse me. So each item in our inventory, and we want to check if it can stack. One thing I do want to do is go to menu handlers, stacking active character. Let's find references to this. Okay, it's only here's where we're pulling it. Very interesting. So we clear it completely. The default values, they're an array of 13 members. Okay. Hey Julio, how's it going? How's it going on your Tuesday? Hmm. So this is connected to here for our item stacking track. So if the item in that array is, if it is stackable, very interesting. I think this can be better optimized. However, for now, we will sort of copy and paste these instructions as they are. Oh, a busy day for you, eh, Julio? I can appreciate that. But I guess it's good in a way. Time goes by faster when you're busy. Okay, the next thing we want to check if the item names are the same, but only if it's true. So let's grab this and grab this. Okay. So we're basically checking to see if these item names are equal to each other from each array. So this is looping our inventory, and this is looping our item stacking. As the array. Okay, so next we should check if the stack is at capacity. Which is basically another branch. Good connection issues. Let's see here. Item index. Oh, it's auto-saving. That auto-save reminds me, we should probably compile and save all. So what we want to do now is, and this gets a little messier, we want to grab our array index from our item stacking. Let's just pull it out as a reroute node for now. Things are going to get a little hairy. We want to set the array element only if it's true, only if we're at capacity. And the index we want to set this to, or the item actually we want to set this to, it's very little confusing. We actually want to set this with this as a target array. Oops, yeah, shove that guy over here, perfect. Okay, my apologies for the technical difficulties of the stream, guys. Looks like, I don't know if these are high bandwidth hours or what, but didn't think it would be. Now then, we want to get this position, and we want to get the position from that same array. But we want to add one. And we basically just want to hook this up like this, and the item to set that stacking array to as the +1. For our decision, we just want to make sure that our item count is actually less than our max stack. All right, collapse that again. try to make this somewhat neat. Oh, whoops, this actually should be connected to, whoops, our max stack should be connected to this branch because we want to see if the stack's at capacity. That would have caused a conflict for sure. Now then, yeah, set array element size to fit, of course. And once we do that, we basically, I think, we can just break this array out. Trying to sort of reteach myself what I did here from doc 1. Comments are proving helpful. I'm glad I made those. But now we have some false to check against. Because like, what's happening, right? If the stack's at capacity, if the names are not the same, we should be creating a new inventory stack / non-stackable items. And we probably could create a local variable and call this item stack just to sort of track that for us. Default should be fine at 0. So this right here, it is a temporary item stack counter for the looping array. And we're just going to get this and add +1 to whatever it is. And we're actually going to route all this good stuff into here from all 3 of these. And then we have to add the final part of our loop, of our stacking check, which would actually be another branch, of course. And we're checking against our item stack to see if it's equal to our stacking array. Yeah, let's grab the length of that array and dump that in here. And if it's true, we finally get to add this in. And the item we're adding is the item we're checking each time. From our inventory, excuse me. And that's really just for true. After that, we set our item stack for false. No matter what, actually, we set it to back to 0, so that we can count our next item. The counting slash stacking loop. Count and if stackable. And we do that for each item in our actual inventory. Now, I want to see where that leaves us. So, for each item in inventory, let's print this out. After, we can reset it. We don't want to ruin our functionality. Let's get an append. And let's get, I guess, something like a bright red. And what I want to check, I want to check our item stack. And we're doing that for each item, so we should be able to just pull out the item name. Put a space in between, save, compile, and let's test out this tracking. We're going to ignore the menu. We know everything. Our capacity is set to 3. Yeah, item stash. We know that has to get fixed, but first, we want to make sure inventory is perfect. So, we have 0 of those. Interesting. Item is found in array. Yeah, we have 2. Let's see here. Yeah, not our item master. Interesting. So, to recap, we take a look at our inventory. And for each item in our inventory, we're actually check to see how many of these items are of the equivalent name. For each one in our inventory that is the same name, assuming they're stackable, of course, we check to see if stack is at capacity, and then we also add to this count. So we add to this count if the names are not the same. If it can stack. Yeah, if it can't stack, we're at 1. If the item names are the same, we add +1. And then we check if it's at capacity. If it's at capacity, we break our count. And I believe that explains why our temporary item stack gave us from 0 to 2 on the display. Yeah, that's a little critical. Okay. Very interesting. So, this might be where we deviate from our initial structure here. So, for each item in our array, one thing I want to do right off the bat is let's check count, right? Because why would we want to check if stackable? Let's actually get a count of our items. Yeah, checks count to see if stackable. Hmm. If the item can stack, I dislike how we are counting from this array here. I really do feel as though we should be checking. Okay, let's things up a little bit. So for each item in the array, let's check against our array. And maybe not break. Let's see. So we look at each item in our inventory, and we check it against each item in the inventory for matches. Okay, I'm going to actually just clear out some space. So far, we've sort of been working with our existing structure on how we should be calculating our item stacks. I kind of want to take a stab at it myself, and I think we may be able to leverage a similar logic as we had for our item sorting. Where we just make use of, in this function, we're able to make use of temporary inventory arrays to calculate our item sorting, and it works wonderfully. So let's see here. Let's get you don't need the array index, but what we do want is our, let's see here. Let's hook that back up nicely. Anyway, so what we do want to check against is our array length of our actual inventory. If I can spell. And for each item in the array, we will have to, sorry, not a branch, we will have to make use of another for each loop. But I don't think we need a break. For each item in our inventory, we want to check for similar items of the same name. So we're going to use a similar. It's going to look kind of similar at first, because I do like how they're checking. Well, I believe maybe we don't even need that. Maybe we can check against actor to actor, like struct to struct, or maybe not. Doesn't look like it. Um, so we will have to use the same logic. And we'll hook this up like so. We don't want to go up there. For each item in the array that is of the same type, let's make a duplicate of this. Yeah, let's just call it item stack 0 for now. It's fine. I do think we should increment this. And this should provide us with the result print string we wanted originally. Because the first thing we want to be able to do is just get the amount of items we have of the same type. Also, we can get an item name. How many? And then we just grab our item stack. And this should provide us with, actually this should be on complete after we're done counting each. Kind of all over the place, but this should be the initial logic we're trying to get. So we have one alloy, not quite what we're looking to count. I forgot to do one important detail. We want to replicate this after counting. We do need to reset our function. So we want to set that back to 0. So we have one, how correct. Gift box. Oh, that is actually why. We want to check for each item. Not that ones we're checking against, which should always be the newest one, which makes sense as to why they all display the same name. But we actually want to check against the actual inventory. Okay, 1, and now, perfect. We have 1 of each of those. 2 E-canteens, so each E-canteen is being counted twice. That's the only, that's the weird part, I guess. Because we're checking each item in the inventory of how many they have like it in the inventory. So then if we have 2 ferroalloy, they both get checked that they both have another one in the inventory. And then now 3 will check for 3. Yeah, sort of what I figured would be the case. So looking at it's a very useful script we have here where we're able to get all the items. I'm just thinking with regards to if I don't think it's a huge deal to count the items we don't. To count against the items we already have. Okay, so what are we doing here? We are checking each item against the inventory for quantity, which we get from here. But the one thing we want to check next is for that item, we want to check if we're at max. Kind of like this. Just to see if stack is at, if quantity is less than max stack. So, let's call this not item stack, but item quantity. So we're counting the item quantity, and then after we're done checking the whole array, start to, yeah, that's fine. After we're done checking that, we need to, I'll have to zero that out eventually. The next, we have to do another check actually to see if, what kind of item it is, which is kind of interesting. This actually may need to be done on our item. This might have to be a function separate from add to inventory, wherein we can check if we can add it to our inventory. The idea being, I need to think about this some more. Well, I think it's reached that time where it's time for me to use the washroom. I'll be right back, guys. Oh no, is there an issue with the stream? What's going on? Okay, wait. I think it's okay actually. Huh, fingers crossed. Okay. Now I should be able to think a little bit clearer. Um, so then we check to see if as we're counting through the inventory, we don't want to check afterwards. I mean, we could add to the count. This is interesting. Super interesting. For the sake of counting, I want to go to my inventory and just make that maximum, like, stupid high. Just so that's not restricting us in terms of counting. Excuse me. Let's take a look at here. As we increase our item quantity, let's check the item quantity against the max stack. If it's less than, we should do nothing. However, if it's false, if it's equal to, let's actually do some interesting counting. Who would have thought I'd find counting interesting? We want to increase our item quantity, our item stack by 1, but then we want to set our item quantity to 0. So we could check it here. We could do this calculation, right? We could do procedurally and count up our stacks against our items, but it may be, you know what, it might be more beneficial for us to check this at the end. After it's done checking against the whole inventory. These wires are getting a little confusing. Okay. Basically, after unchecking against everything, we should get our item, our max stack, and actually divide our counted quantity into our max stack. Which should give us our amount of stacks. Just to verify. Just want to make sure I'm getting that data right. So for each one, we want the item name. Quantity equals that amount. Then we want to check our quantity per stack. Yeah, something like this. Quantity per stack. Afterwards, we need to... Well, it's kind of simple, I guess. We just plug this directly into our quantity. Number of stacks. Cool. So that print string should read out and give us some valuable information. One thing I do want to check is, let's set the item, the max stacks to 1. Then we'll adjust to 2 and so forth. Alrighty. So forgot that critical step. We absolutely need to, well, let's color code that differently too over here. But what we want to do is sort of compile against actually reset both of these for each item back to 0, so we're not getting these multiples happening. Because those are our counters. So, quantity 1, quantity 2, quantity per stack. So there's 3 of them, 1 per stack, 4. Okay. Yeah, it checks out. We have 6 for 6. Okay. Now, for items that, let's say, can stack to 3. Whoops, not 36. 3. One thing I do want to do is make this last a little longer. Whoops, that's way too long. And display each of those for 5 seconds. Should be cool. Save that. It's a weird graphical glitch that happens sometimes. You can actually resolve it. You might be worried because you can't click on any of these items, but if you just close your tab and reopen that blueprint, it'll actually refresh the user interface here in Unreal. And I'll move it over. And now we can compile. So got our item stash. Let's open this up. And, okay. Number of stacks is 0. Very odd. Of course, because we're dividing by those two values. Kind of works, but we want an immediate amount. So you don't just want to divide by this. I believe we want to add 1 because this starts at 0. I mean, conversely, we could just have to add +1 actually. The item stack value should by default not be 0. It should be 1. It makes logical sense. You should always have at least 1 stack. Quantity should be at 0. think that makes sense. So I want to make sure we have an inventory system that before we work on displaying these stacks and where to calculate it, that we have the right logic in terms of counting our inventory and displaying the right amount of slots. Because I have a feeling that we're going to have to create this as a separate function, possibly on the game mode or on the character, the main character, because we want to, whether we're going to be buying new items, picking up items, getting items from chests, we want to make sure that we're pulling items from our stash. We need to make sure at any of those points that we're able to, whether or not we can add that specific item to our inventory based on total slot size, based on stacking as well. So we're sort of just building the base logic here on the pickup interaction, but we may most likely will be moving this to a separate function. Anyhow, let's continue. So, number of stacks are 0 still. Well, that's so funny. Yeah, of course, we're not even referencing this anywhere. What we should be doing is adding this to our item stack, and this is where we pull that value in, because yeah, we want to see how many items we have to go into a stack, but as soon as you have one item, you should have a stack. So this logic here should be able to calculate it accurately. One thing I should do is, we don't need to have the item stash here. Let's just save, and it's like needless error pop-ups. Right, so one stack, max quantity is 3. So we're checking red to blue, really. So 2 to 1, as soon as we have 3, we should actually have 1. Still displaying a little incorrectly. As soon as we have 6, it's going to go up to 3, and that's not what we want. Let's take a look at this. We are basically dividing our item quantity by our total stack. In this case, it's 2. And we're using an integer, so that's why we can only get whole values, which is, I believe, the right way in this case. Perhaps. Perhaps to set this value as opposed to getting it and adding in dynamically like this. We do want to find out how many times this our item count can go into our item stack. Because it will allow us to get the data we need. Oh geez, it looks like the stream is having a lot of issues. I'm gonna stop a little early today. Hopefully we have better luck tomorrow. Um, anyways, anyone who watches, thanks. We appreciate the views and the subscribes and all of that. It helps us a great deal as we move towards, as we put in the hard work and move towards our own goals here. I appreciate it so much. Anyhow, guys, thanks for watching. Hopefully we'll be back tomorrow with a stream of better quality.